So now in this video, we have a 555 timer in astable mode, except for we're not using the output. We're looking at the voltage of the capacitor that's charging and discharging. That voltage being sent to our op amp. I'm using an LM358 wired as a voltage follower. So as the voltage of the capacitor rises to 2/3 supply voltage, the output rises accordingly. And then as it lowers to 1/3 supply voltage, the output lowers in the same direction right there, which makes it so the LEDs are fading on and off depending on which side of the power supply they are headed to. We'll get to that later. But in any case, you can see when one is fading on, the other one is fading off, and vice versa. Now I'm also using a breadboard power supply. A lot of people are interested in the breadboard power supply. The basic video I made is my most popular video by far. So this is plugged into the outlet, and you know, it has AC over there, and then it converts it. Comes down the wire as 9 volts DC right there. That's how we're powering this. The breadboard power supply, when it is on, as it is now, since I have this jumper there to 5 volts, it's powering that rail at 5 volts. Same with this one. Since I have the jumper there, it's 5 volts. If I move the jumper over, that will cut the power there. Or we can move it over another one and get 3.3 volts. Same goes with this side. There's also pins right there. I gotta be careful. I did short this earlier. The top two on the left are 5 volts out. You can plug a female end of a jumper and plug the male wherever you want into the breadboard, in this case for 5 volts, the top two. The bottom two right there are 3.3 volts. The reason why I gotta be careful of a short is this is ground right there. It says ground. All 4 of those pins, they're separate pins headed to ground, same as plugging into the negative side of one of these breadboards right there. And then we also have this USB. Right now we can plug a USB in there to alligator clips and have 5 volts available, but this is not intended to provide a lot of current. Don't power USB devices. Or you can remove the plug and take a USB to USB and use the USB to provide 5 volts. I've done that in other videos. Some people are interested in that, but that's all we're going to look at when it comes to power supply for now. So now I'm going to do a step-by-step build. I removed power right there. That's one nice thing about the breadboard power supply. You just pop it out. You don't have to worry about accidentally powering the rail anymore. I did forget this jumper when I built the circuit. And that's pin 4 going to the positive supply. It's really not doing anything in this circuit anyways, but all this jumper does is make sure it definitely doesn't do anything in this circuit. So if the capacitor would have completely discharged and kept staying discharged, we would have known that we got a low enough voltage at the reset pin, but it was just floating, and we didn't run into that problem, but we may have. So in any case, there we go. That's all it's doing, preventing the reset pin from doing anything. Pin number 8 over here is the positive supply, VCC, and then pin number 1 is the negative supply, right there, ground. And so now we got the 555 time powered, and we're going to start with this resistor up there, 100K. This helps set the timing right there, 100K. And then we have pin 2 and pin 6 wired together. I'm going to do that right now just because it's kind of an awkward jumper right there. I need it in that close spot. I want to make sure I keep that close spot clear. Now when it comes to the capacitor charging, it goes through 100K and then the diode. Otherwise it'll take twice as long going through 2 resistors. And so we're going to take the diode, and I usually set it off to the left over here when I build my circuits. And I could set it over one more spot, those 2 rows, but I'm not going to. Pin 7 is the discharge pin, by the way, when the output is low, which we don't have going on in here. When the capacitor is discharging, pin 7 is connected directly to ground. It discharges through the resistor to ground. When the capacitor is charging, it's not connected to anything, it's off, so the capacitor can charge. So we got that charge path set up, and then we'll grab our discharge resistor right there. So the capacitor will charge through the diode and then discharge through the resistor because it can't discharge through the diode. The diode is reverse bias when it's trying to discharge. So gray band is down lower right there. That's the cathode. You put the gray band where you see the band on the schematic. Pretty straightforward. So I'm going to use a 10 microfarad capacitor right there. Again, exact values don't really matter, but if you go larger in values, it's going to go slower, the fade from back and forth, and lower values, it's going to go faster. And then you can, go higher on one, lower on the other one to get about the same timing, and so on. when it comes to the resistors and the capacitors. Pretty straightforward. So that's it for the 555, except we're going to add a jumper. By the way, pin 2 is waiting for the capacitor to discharge to 1/3 supply voltage, and then it will stop connecting 7 to ground. While the capacitor is charging, pin 6 waits for 2/3 supply voltage. And once it gets to 2/3 supply voltage, pin 7 connects to ground so that it can discharge. Basic 555 timer stuff. We're not going to dwell on that. So our capacitor voltage right there. It's really cramped right there. Every spot is taken. But luckily we got a jumper that's transferring that voltage to pin 2. Again, it needs to look at the same voltage as 6 in this particular circuit. So this is an op amp. There's 2 op amps on here. And it's best not to leave it floating, but I find it's okay to leave that one that we're not using floating. The very top one is a positive supply, VCC. Right below it we got the output, inverting input or minus, and then below that is plus right there, non-inverting. So it's the same over here, but it's shuffled up one spot. So you can see we have the output tied to the inverting input. This is how we're transferring the voltage here to the LEDs, because this is not strong enough to light LEDs. So we got a voltage follower. The op amp's going to look at the voltage of the capacitor and make the output the same within the limits of the op amp. So does decent enough job though. So in any case, we're going down to the plus input right there. See the minus, the inverting, is already to the output. So we don't have to worry about that. Now, we got the LEDs. Let's do this one over here. So you can see we got a ground jumper right there. So we're going to take this LED and make sure the short lead, the cathode, is to where the gray jumper is. I'm going to slide it over here so that the LEDs are a little closer to each other. But there you can see that lower one is the shorter one, and there's also like a shaved edge on there, but not all LEDs have a shaved edge. So you may not always be able to go by that, but often you can. Now, 220 ohm resistor is a pretty good value to protect a red LED from 5 volts and also have the LED, be relatively bright. Now, the other LED is coming from the positive supply right there. So it's a little awkward area here. We're going to swap the position of the LED and the 220 ohm resistor, but we need the short lead, the cathode, headed to the output there. So I'm going to plug the short lead, the cathode, directly to the output. And then up here, we are going to take the 220 ohm resistor and put that to the positive supply. So we're just shuffling the positions of the LED and the resistor. And it doesn't matter which direction the resistors go, they are not polarized. LEDs are. And need the anode more positive, the cathode more negative, and that's it. So breadboard power supply is already got the power there. If I press the button, it will turn on. If I turn it off, press the button again, it will turn off right there. But again, this is plugged into the wall, the AC, 120 volts, and the adapter turns that into 9 volts DC, direct current right there. And then the unit here takes that higher voltage, it should be at least 7 volts, but it takes a higher voltage and regulates it. So it's kind of like, these two parts right there are kind of like a resistor in a sense. It kind of limits current as needed to maintain 5 volts at the output when 9 volts is coming in. That's kind of the way to think of it. It's just waste heat, that extra voltage, those 4 extra volts. But now, I'm going to turn it on, and we should be wired properly. It should be working just like it did. One LED will probably be on slightly longer at the beginning. If this capacitor was completely discharged, then it has to charge up to 2/3 supply voltage, and then only discharge to 1/3 supply voltage. So that initial high time, higher time, rise time, I should say, might be a little bit longer than it is otherwise. But once it gets to 2/3 supply voltage, it'll just keep bouncing back between 1/3 and 2/3. So these should be pretty close to equal times right there, the way we wired this up. Again, if we removed the LED, which is fine, or not the LED, the diode is fine. But yeah, looks like this one is staying bright longer than it is dim right there. And then this one is bright for a shorter period of time and dim for a longer period of time. So probably about twice as long, because there's twice as much resistance to discharge as charge. So you don't need that diode, but it helps a lot if you want close to what's called a 50% duty cycle. Duty cycle is how long the output is high. And so 50 means half the time. 50% of the time it's high, 50% of the time it's low. That's the output though, not the LEDs. And we're not using the output. But in any case, there we go. Yeah, we can get that all in view, and I think you can see it pretty good. So that's how we're getting that fade. That's the way I like to do it for this effect. You can find other ways to get a rising and lower voltage. They may be able to, you know, power the LEDs wire like this by itself, and it may not. If it's not strong enough to power it by itself, you send it to a voltage follower. We're using an op amp as a voltage follower, and it's looking at the voltage of the capacitor and outputting, you know, hopefully the exact same voltage. But you know, there are power limitations with the op amp though, so it may not do so perfectly all the time. But in any case, that's it. Hope you enjoyed. Make sure you check out one of the other videos I'm posting on the screen, and check out links down below. They all help out a lot. I'll see you in the next video.